Hello everyone, this is our mini project presentation which we have named Graphing Calculator. This is our team, myself Ahmed Faisal alongside Abdullah and Muhammad Haikal. Our project is a simple project with the purpose of demonstrating some of the mathematical theories that we have learned during this class and to be able to provide graphical illustrations for them. The motivation behind selecting this as our project topic was simple curiosity, and we believed that it posed a challenge which we intended to overcome. The overview of the mini project is that the program can process the polynomial equations into a graph and calculate the roots. The features that we have added is that the program will be able to define the roots of linear, cubic, and quadratic equations, as well as be able to provide graphical illustrations for each function. The purpose of this assignment is to incorporate the techniques of computer graphics mathematics into a C++ program. Topics that we have used in this project are from the chapter Linear and Nonlinear Equations, which include the following subtopics. Here are a few snippets of our code. The first function, which is void menu, just provides a menu for the user to select based on. And then we have another function, which is the getQuad, which calculates the quadratic roots. And as you can see on the bottom right corner, this is a graph based on the function that we have entered in the above segment. Now moving on to the actual code.
Hello. After you run in the program, there will be five options that you can choose, but only four operation that is uh, gonna be used in the program. So the first one, which we wanna demonstrate, which is find the area under the line, and also calculate the roots of the linear equation. So we can. So for example, for the first input that you're gonna have is enter a gradient for the linear equation. So we're gonna put 5. The second input, which is a y-intercept, which is c, so we can choose a number 8. And then they will output a root for the linear equation, and then the program will ask if you want to find the area under the graph. So you need to enter the y, capital Y or small y, so to proceed. So we're gonna proceed it. Okay, the program then asks for you to input the first limit of your area. So we're gonna put 8. And then the second limit, we can also put number 5, I guess. So now the program will output or display the graph for the linear equation that we put. So, and then the graph, the program will output the area of the line. So it will be 12.5 unit square. And then the program will ask either you want to continue the operation or you want to go back to the menu. If you don't, then the program will be exit. So yes, we want to run again. So why? So it's okay. We back at the menu, and then we gonna demonstrate the second operation, which is find the roots of quadratic equation and graph that equation. So the first coefficient in the enter is the square one. So a squared. So the a is gonna be 1. Okay, the second coefficient is the power 1. So we're gonna choose 4. And then the c, and then we're gonna choose 8. As you can see, the graph for the equation that we enter. Now we can proceed, and then they will show the roots of our equation, which is -2 plus 2i. So again, the program will ask you again if you want to go back to the menu or you want to exit the program. So yes, we want to proceed with the next operation.
Okay, before I do my part, I want to change something in the menu. Um, So for option three, I want you to write integer numbers, not real numbers.
For choice three,
Yeah, yeah, yeah. Because we're
uh,
not
the
real
menu,
numbers are also like fractions. Yeah, go to menu,
yeah, this one,
integer uh,
integer,
integer roots, integer roots.
okay, integer,
Remove number. Integer roots.
okay, just want to make sure that it's was, okay, never mind, it's fine, okay, run, what is, I'm so tired of
You
this
you
program.
have four. You have four. Number four or something
What,
after a key.
why is that there?
Why do you keep writing fours?
I think it's the shortcut for the recording. Okay, go.
And now we'll be moving on to option number three in the menu. So option three finds the roots, the integer roots of the cubic equation. So here we'll be entering the values of the a, b, and c coefficients in the equation of the cubic equation. So a here will be 1, while b will be minus 2, c will be minus 5, and d will be 6. So as you can see here, this is the graph of the of our cubic equation. So next will the what the program will do is it will show the roots of this equation. So as you can see here, root number one is minus two, root number two is one, and root number three is three. So then the program will ask us if we want to perform another operation, and we will choose yes here because we still have the option number four. So option number four here is the slope of 2 points. So we'll choose option number four. And then the program will ask us to enter the coordinates of the first point and the second point. So our x1 now would be 6. Our y1 would be 10. Our x2 would be 10. And then our y2 would be 14. So the slope here is 1 because in the equation of the slope, y2 minus y1 divided by x2 minus x1 will give us 1. So the program here will show that output. And then the program will ask us if we want to perform another operation, in which here we would choose n or no, because this is the last option or the operation in the menu. And then the program here ends. And yeah, that's it. We also have another option. So if you can run the code again. So option number 5 here exits the program. So if you press 5 here and enter, the program will display thank you for using this program. So it will display this message and then the program will exit and end. That's it.
Alright, so now that we have taken a closer look at the code in depth, we would like to conclude this presentation by saying that throughout this course, we were able to acquire the necessary skills to be able to apply these mathematical concepts that we have learned, not just in a theoretical way, but also in a more practical way, as we have just demonstrated. And with that, we would like to end our presentation. Thank you so much and have a good day.